In this demonstration, I want to briefly show how to use support vector machine as one class classifier. In the R file, I included two examples, one using the ARIS dataset, the other uses our police shooting dataset. I'm going to demonstrate the police shooting part, and once you understand the police shooting part, you can go up to the IRIS example, and you should be able to understand that very well. Again, post questions if you have any. In this exercise, I also include a new library. Carrot is for machine learning. It has some very convenient ways. Carrot also provides support vector machines, but we're still using this old support vector machine library in this example. But I encourage you to explore. So one class classification, right? So we understand for one class classification, we only need to provide examples that belongs to one class. And we will then give this trained model new examples and see if this model can predict the instances that belongs to this class and separate those from examples that do not belong to this class. So we have a set of packages listed here, and the carrot also, but in this example, I did not use carrot features or functions. So again, get our data in to do the typical pre-processing, remove the NAs, convert data type to factors. So now to demonstrate the one class classification problem, I'm going to only select training examples with race equals to white. This is going to be my positive example, so the normal example, the class that I want the system to learn. And I will select the race equals Asia as our other class, and I'm going to use this as a test example. I want to know if the classifier built using the white race, can this classifier classify my test examples as negative, so non-white. So this is my setup. So I select those white race cases as my training, and my test going to be the Asian race. I'm going to, in the train and the test, I'm going to reset the race to be either true or false, so it's easier for us to interpret the result from the one class classifier. So true is our normal class, false are the outliers that I want to detect. So those Asian. So let's do that. So now we're going to run the support vector machine. We use it many times already. So earlier we used the type as classification, and now the type is set to one classification. Okay, so this one going to do one class classification. Again, we're going to use our available attributes to predict a race. The data is the train. So remember, in train dataset, the only class we have is white. For one class classification, we need to provide a hyperparameter new. And this new is similar to the cost parameters that we use for the typical support vector machines. So they cost the penalties on misclassification. I pick this is an arbitrary number, and I encourage you to experiment with our tuning strategies to find the best values. And in this case, we use a kernel, the radio, radio and linear are the most typical selections. So in this case, I'm going to use radio. So I do my one class classification. I'm going to ask for the model. So summary of a model. We have caught this. This gave us what we told it to do. It's one classification. It has the nu and the gamma value. We have 190 support vectors. I think this number of support vectors is certainly less than the number of white cases that we have. So now we can use this model to predict our training example. It should not be perfect because we do actually allow errors, right? So let's do this. And again, I'm going to collect the predictions on our test. So this is outliers that I want the system to be able to identify. And then I'm going to use the typical table function to create my confusion matrix. So here I can tell it to use our prediction as a predicted, so label it as predicted in the confusion matrix, and the label race as labeled in the confusion matrix, so it's easier for us to read. And I do the same for the test. Now I'm going to print the train result. So the train result shows that the labeled says true, so those are white cases, right? So the labeled, the true is a lot. All of them are true. Remember, this is a one-class classification, so here everything is true. The system was able to, using this model selected, we allow it to have errors, so it actually picked out vast majority of them. So over 1,600, we have a total case over 1,800. It picked out over 1,600 to be true. So on the training, it looks okay. Let's look at the test. So in test, we only have non-white. So we expect if this model is actually good, it should differentiate. It should say all the examples in test are actually false. So let's see. It only found 6 to be false. Majority of those cases, the one class classifier still identify it as white by mistake. So this actually, I tell you, it highlights the challenge that one class classifier, right? It only have information of this positive class. How does it know the negative class is actually not overlapping? Basically, we see that it is not very easy to separate pre-shooting cases that involving Asia from those cases from white race. I think this largely confirms what we have found in the past, that the given attributes are not very effective in terms of the differentiate race involved in a police shooting setting.